I first visited the old Central Rail Depot in Dresden on Wiener Platz. Official records state construction began in 1892 under engineer Ernst Gieser. I expected the usual late 19th century ironwork, prefabricated trusses, riveted lattice beams, steam-era pragmatism. But an 1894 construction photograph lodged in the Saxon State Archive showed something that contradicted that assumption: a sub-foundation chamber with an arched hydraulic recess far too symmetrical for hand-cut stone and curiously polished, as if machined. The depot was documented as a straightforward Victorian rail hub, yet the masonry suggested an earlier structural logic. A renovation record from 1926 mentioned the removal of pre-existing channels of unknown purpose. It was a minor note, but it echoed descriptions found in what some researchers classify as Tartarian infrastructure: buried conduits, pressure-regulated chambers, unexplained stone precision. I tried to dismiss the detail, but the chamber's radius repeated too cleanly. Something subtle and older was embedded beneath the depot. The official narrative places Dresden Central Rail Depot firmly in the late industrial period. Construction was initiated in 1892, foundations laid in early 1893, and steel assembly completed by 1897. The architect of record, Ernst Gieser, was known for combining stone plinths with iron roofs, nothing unusual for German railway architecture of that era. Yet the photograph I found in the Saxon State Archive, labelled Substructure East Wing March 1894, showed a detail that did not align with any of Gieser's typical methods or the documented construction timeline. The camera captured workers standing on a half-excavated platform, their tools resting against temporary scaffolding. Directly behind them was a stone arch recess, smooth, elliptical, and carved from what appeared to be single blocks. Its curvature measured in the photograph approximately 3.4 meters across. By cross-referencing with a surviving section of the east retaining wall visible in later photographs, I estimated the deviation margin at less than 2 centimeters across the entire span. That precision alone was troubling. Period stone cutting, even in experienced hands, rarely achieved such consistency without mechanical guidance systems that would not become standard until decades later. More concerning was the hydraulic scarring, vertical grooves in the stone, evenly spaced at intervals of approximately 40 centimeters, as though a fluid-driven mechanism had once been anchored there. The grooves showed wear patterns consistent with repeated pressurization cycles, yet no such system is mentioned in any construction document I could locate. In the 1895 Progress Journal kept by the site foreman, a brief entry reads, "Prior formations appear inconsistent with planned foundation pattern, but the comment was crossed out in different ink and replaced with standard correction, completed." The facility's blueprints, preserved in remarkably complete form, show only compacted gravel beds and load-bearing brick footings, not polished stone vaults with hydraulic infrastructure. The original specifications called for standard Victorian foundation methods: excavation to bedrock, gravel compaction, brick coursing, and then iron column placement. Nothing in Gieser's documented approach suggested he would incorporate pre-existing stone chambers, much less ones exhibiting this degree of geometric precision. Some alternative researchers refer to these vaults as remnants of Tartarian hydraulic infrastructure, systems discovered and overwritten during 19th century construction projects across regions that appeared on 18th century maps as part of Great Tartary or Independent Tartary. I was not prepared to entertain that interpretation yet. The term itself carried significant controversy in academic circles and was often dismissed as pseudo-history. But the physical discrepancy refused to settle into a comfortable explanation. Why did Gieser's team build over a chamber that required no structural support? The vault appeared load-bearing, yet the depot's weight distribution system made no use of it. If it was simply an obstacle, why not remove it entirely instead of incorporating it into the foundation? And if it was incorporated intentionally, why does no construction document acknowledge its existence? My reflection at the time was mild, almost dismissive. If the vault predates 1892, why is there no record of its discovery during initial excavation? The question lingered longer than I expected it to. When I returned to the depot with the 1894 photograph in hand, I followed the corresponding alignment, east wing, lower level, beneath what is now Track 4. Renovations in 1998 sealed most of the old maintenance corridors with modern concrete infill, but one access hatch survived behind a bolted panel in the baggage handling area. With permission from the depot administration to review archived schematics for historical documentation purposes, I located a corridor segment documented in a 1901 maintenance log as non-essential service passage, though the construction clearly predated that designation. The walls were unusually thick, ashlar blocks, some measuring over 1.5 meters in depth. Their surfaces carried faint linear cuts, too straight for traditional chiseling techniques and too consistent to be incidental tool marks. The cuts showed no variation in depth or angle across multiple stones, suggesting some form of guided cutting method. Approximately 7 meters into the corridor, I noticed a vertical seam, a sealed doorway, whose contour matched the curvature visible in the 1894 photograph. The mortar binding it was significantly newer. Chemical analysis later dated it to the early 20th century, consistent with the 1901 renovation period, but the perimeter stones themselves were not. They bore the same polished finish and curvature ratio found in the earlier photographic evidence. A maintenance report from 1903, preserved in the City Building Department archives, contains a peculiar entry that states secondary portal sealed due to absence of mapped connection. That phrasing struck me as carefully chosen. One does not seal off a doorway merely because its destination is unmapped. Standard procedure would be to investigate, document, then make a determination. Yet the report treats the sealing as routine maintenance, with no indication that anyone explored what lay beyond. I measured the arch's geometry using photogrammetric analysis, comparing the physical doorway with multiple historical photographs taken from different angles. The radius measured 1.7 meters, precisely half the 3.4 meter radius of the major chamber visible in the 1894 photograph. The ratio, a clean 1:2, was too exact to be coincidental. This proportional relationship mirrors patterns observed in structures that some researchers attribute to Tartarian architectural principles: proportional harmonics, nested arcs, and mirrored spans designed for fluid pressure equalization in hydraulic systems. In the industrial context of 1893 Dresden, such geometric discipline would have been unnecessary for a simple railway depot. If the curvature were decorative, which seemed unlikely for a buried, invisible passage, it would typically show some variation, some human irregularity. But this was mathematically precise, suggesting either sophisticated surveying equipment or the preservation of an existing template. It was completely hidden from view, buried beneath the depot's functional spaces without any aesthetic purpose. I left the passage with a growing sense of unease. If this doorway predates the depot's construction, what structure required such precise, geometric relationships in its underground chambers? What system demanded this level of mathematical consistency? The question remained unanswered, and the doorway remained sealed, its destination unknown, its purpose undocumented, its very existence unacknowledged in the depot's official history. While reviewing the depot's original construction drawings at the Dresden Building Archive several weeks later, I encountered Sheet C14, stamped February 1893 and showing sub-foundation drainage plans. The sheet lists C. Hartmann, a civil engineer with the Royal Saxon Building Administration, known for his work on municipal waterworks, as the primary drafter. The document appeared routine at first: standard drainage layouts, soil compaction notes, foundation depth measurements. But the lower left quadrant caught my attention, a faint, nearly erased semicircle beneath the notation for the east platform area. I requested a high-resolution scan of the sheet, then adjusted the exposure and contrast until the erased lines became legible. The semicircle matched precisely a 3.4-meter radius from the 1894 photograph and the chamber I had calculated from the physical evidence. Hartmann had drawn it, then deliberately attempted to erase it. Analysis of the pencil marks showed two distinct actions: the initial light outline drawn with a drafting compass, and the heavier abrasion marks indicating intentional removal. The erasure was not complete. Fragments of the arc remained visible under proper lighting. Above the erasure, partially obscured but still readable, a notation in Hartmann's characteristic script read, "Existing curvature, retain." The question mark was particularly significant. It confirmed that Hartmann's team discovered the chamber before the foundation was poured. They mapped it, they questioned how to proceed with it, then they erased it from the official record. The official construction summary, filed with the Royal Saxon Ministry of the Interior in July 1893, states explicitly that no substantial obstacles existed on site prior to excavation, and that soil conditions were favorable for the planned foundation system. That claim is demonstrably false. The erased semicircle proves that Hartmann's team encountered a significant pre-existing structure, one substantial enough to warrant notation on the drainage plan, yet ultimately deemed unsuitable for official documentation. What struck me most was the blueprint's orientation grid. Standard practice for German engineering drawings of this period used true north or magnetic north as the reference axis. But the erased semicircle aligned not with Giza's design axis, nor with true north, but with an older directional scheme rotated approximately 11 degrees eastward. I verified this by overlaying the drawing with contemporary city survey maps. This rotational offset is a pattern I had seen before. It appears consistently in star-shaped fortifications and domed complexes across Central Europe and Central Asia, structures that some researchers classify as belonging to Tartarian architectural traditions. Many such structures, when examined closely, show this curious misalignment with later city grids. The Star Fort in Vyborg, Russia, exhibits 10 degrees of rotation. The Citadel complex in Bukhara shows 12 degrees. The fortress architecture in Kazan displays 11 degrees. These are not random variations. They suggest a different surveying convention, perhaps one based on astronomical alignments or on magnetic declination measurements from an earlier period. I compared the depot's erased semicircle overlay with an 1843 city plan of Dresden, the most detailed pre-depot survey available. The location showed no prior building, no fortification, no documented hydraulic works. The land was classified as undeveloped municipal property, formerly agricultural. Yet the chamber existed, the sealed doorway existed, the erased semicircle existed. As I prepared to leave the archive that evening, carefully returning sheet C14 to its protective folder, my reflection was restrained but persistent. Why would engineers in 1893 deliberately erase evidence of a structure they did not build? Why does its geometric orientation echo patterns found in regions once labeled Tartaria on early modern maps? A pattern was emerging, though I was not yet ready to name it. My next line of inquiry led me to the Deutsche Fotothek in Dresden, where I requested access to unpublicized construction plates from the depot's building period. The standard published photographs show the depot's steel framework assembly and the grand opening ceremony in 1897, but I was looking for earlier images, the excavation phase, the foundation work, the moments when workers first encountered what lay beneath the site. Excavation. Among the archival materials was a stereoscopic pair dated November 1893, East Retaining Section. Stereoscopic photography was relatively common for documenting major construction projects during this period. The three-dimensional effect helped engineers assess spatial relationships and structural details. Arches. The images showed several workers positioned beneath temporary wooden scaffolding, their poses suggesting a break in the workday. Behind them, partially obscured by scaffolding shadows, were three contiguous arches, uniform in curvature, each carved from what appeared to be single-block stone. The official records claim the depot's lower levels were constructed using machine-cut sandstone blocks transported from quarries near Pirna, approximately 25 kilometers southeast of Dresden. The quarries were well-documented suppliers for Saxon building projects throughout the late 19th century, producing standardized rectangular blocks suitable for load-bearing walls. Yet these arches, each approximately 1.7 meters wide and matching the dimensions of the sealed doorway beneath track 4, were monolithic, not composite assemblies. Monolithic. Industrial stone cutting technology of the 1890s could produce straight cuts with reasonable precision using steam-powered frame saws with diamond-tipped or hardened steel blades. But curved cuts of this complexity required either extensive hand chiseling, which inevitably produced measurable variations, or specialized equipment that would not become available until much later. To carve three identical monolithic arches with uniform curvature would have required not only advanced cutting tools, but also sophisticated measurement and replication systems. Technology. I conducted a detailed photogrammetric analysis of the stereoscopic pair, using the known dimensions of the workers and scaffolding components as reference scales. The curvature deviation across all three arches, measured from multiple reference points, was under 1.2 centimeters. For hand-carved stone, even by master craftsmen, this level of consistency would be extraordinary. For three separate monolithic pieces, it suggested either a level of craftsmanship far beyond typical commercial stonework, or the use of some form of mechanical template system. Precision. That precision matches something else I had encountered in my research, a series of monolithic arches photographed in Shamali-Zinda near Samarkand, in regions clearly labeled Great Tartary on 18th and early 19th century European maps. Alternative researchers studying Central Asian architecture have noted these repeating geometric patterns, identical curves, proportional relationships, and construction techniques appearing across vast distances. The hypothesis, controversial in mainstream academia, suggests a common engineering lineage rather than independent development. Lineage. A construction journal entry from Foreman M. Leiber, dated December 1893 and preserved in the Saxon State Archive, records that indigenous stone formations presented unexpected uniformity, that they were not part of contracted work, and that orders were received to preserve foundation integrity and build over. The phrase indigenous formations struck me as a carefully chosen euphemism. Indigenous. Indigenous to what? The soil or the site? These were not geological features, they were clearly worked stone with deliberate geometric properties. The note that they were not part of contracted work confirms these arches were not created by Giza's construction team. Confirms. They were discovered, assessed, and ultimately incorporated into the foundation, but never documented in the official project records submitted to the Ministry of the Interior. The arches should not have existed in Dresden in 1893. No record of their creation survives in municipal archives, guild records, or private construction logs. No invoice documents their procurement. No transport records show their delivery. Yet they stand in the photographs as if waiting, patient, precise, and unexplained for the depot to rise around them. Who built structural elements so geometrically perfect that 19th century engineers chose to bury them rather than attempt to dismantle them? And were these arches remnants of an earlier infrastructure, perhaps what some classify as Tartarian sub-foundation architecture? I turn next to the depot's freight wing, officially constructed in 1896 under engineer Carl Schmidt, whose reports emphasize the installation of modernized drainage conduits. Technical drawings from the period show simple ceramic pipes 30 to 40 centimeters in diameter, standard for the period. A municipal repair ledger from June 1907 revealed something more troubling. An entry notes that lower conduits discovered during freight platform expansion were not recognized in city schematics. Stones were removed for assessment. Channels were sealed with Portland cement. Attached was a sketch showing two buried conduits running parallel beneath the freight wing, each approximately 80 centimeters in diameter, vastly larger than Schmidt's documented ceramic pipes. The sketch described the material as dense alloy stone, a term that appears in reports from the 1860s in Prussian hydraulic literature, and that refers to stone with a ferrosilicate infusion, whose density far exceeded what Dresden masons could produce. I located one surviving conduit segment in the depot storage vault. The segment measured 1.2 meters in length with an 80 centimeter internal diameter. Its exterior showed a fused grain structure, as though chemically bonded rather than carved. Under magnification, the surface revealed no tool marks, just a uniform, almost glassy finish. This echoed descriptions of buried conduits in Irkutsk, Kazan, and Omsk, cities that appear within boundaries labeled Tartaria on maps from before 1800. Each site features oversized conduits beneath later construction, diameters too large for residential water supply, material composition too advanced for local capabilities, and internal bores too uniform for hand production. The Dresden segment weighed approximately 40% more than comparable sandstone volumes. Its inner bore was cylindrical within 3 millimeters of tolerance, as though cast or machined. A 1911 engineering memo noted that the removed pipes showed no jointing, a seamless interior, and a purpose that was unknown. The physical evidence contradicted every construction record. Schmidt's team found these conduits, failed to explain them, and sealed them away. If these conduits predate the depot, who engineered them with such precision, and why were builders instructed only to seal and document nothing further? Following the freight wing anomalies, I examined structural load plans from 1895. Sheet D7, labeled Subsoil Pressure Assessment, Western Concourse, contained a circular zone approximately 9.8 meters in diameter, annotated irregular firmness, monitoring required. A 1972 renovation report noted void stabilization measures applied to a circular cavity of unknown origin beneath the Western Concourse during foundation reinforcement. Cross-referencing the 1972 map with the 1895 assessment revealed near-perfect spatial correlation. The cavity had maintained structural integrity for 77 years, suggesting construction quality far exceeding typical subsurface voids. The cavity proportions matched what some researchers call a Tartarian pressure dome, structures described as designed to distribute hydraulic loads through radial channels. While terminology remains contested, the geometry matched circular substructures documented beneath stations in St. Petersburg, Warsaw, and Tashkent, all sites built over inherited infrastructure. Inside the depot archive, I found a wooden support cylinder removed during the 1972 stabilization. Dendrochronological analysis confirmed growth patterns from trees harvested around 1870, 2 decades before the depot's construction. the cylinder bore compression marks that indicate insertion into a pre-existing cavity, not part of any depot-era foundation. An 1895 journal entry by Hartmann mentions that the subterranean void beneath the western platform appears not to be collapse. The geometry is too regular for natural formation. Yet no follow-up exists, no drawing, no explanation. Walking the western concourse with historical plans overlaid digitally, I noted the pattern. The circular cavity's alignment matched an 11-degree rotation from the erased semicircle. The conduits exhibited proportional relationships to the arches, 80-centimeter conduits serving 1.7-meter spans. The 9.8-meter cavity was 6 times the 1.7-meter arch span, another clean harmonic ratio. How many layers lie below this depot? None belong to 1895, yet all exhibit the same architectural DNA found in structures that alternative historians classify as Tartarian. The depot was becoming less a constructed building and more an inheritance from something older, geometrically sophisticated and systematically undocumented. To understand whether Dresden's geometric ratios were isolated or part of a broader pattern, I compared the depot's measurements with archival databases of late 1800s railway construction photographs across 3 continents. A 1901 photograph from St. Petersburg's Warszawski station shows sub-chambers with stone arches measuring approximately 1.7 meters, identical to Dresden within the margin of error. Official records call these temporary construction vaults, yet the masonry appears older than the station's superstructure. Budapest's Nyugati station, 1877, presents similar anomalies. Excavation photographs from 1875 show circular sublevels beneath the main concourse, approximately 10 meters in diameter, matching Dresden's 9.8-meter cavity. Survey drawings show a 10-degree rotation off the station grid. In Tashkent, beneath the old Chorsu district, marked as independent Tartary on 1780 atlases, 1960s archaeological surveys documented conduits with ferrosilicate composition and fused surfaces, internal diameter 80 centimeters, precisely matching Dresden. These sites share 3 characteristics: identical geometric ratios of 1.7 meters, 3.4 meters and 9.8 to 10 meters, pre-industrial masonry predating official construction, and 10 to 12 degree rotational offsets relative to later city grids. Official histories list no exchange of plans, no shared engineering consultants, no cross-continental masonry consortium. Yet subsurface geometries align with mathematical precision. An 1888 Hungarian memo states substructure not of recent origin, chambers considered stable, construction may proceed above. Nearly identical phrasing appears in German, Russian, and Uzbek archives. The pattern was global. The silence was equally global. Why do structures built across 3 empires during the late 1800s sit atop architectural signatures with identical proportions found specifically in regions once labeled Tartaria, yet contemporary engineers never acknowledged them in official documentation? Dresden was not an anomaly. It was one instance of a repeating, mathematically consistent, geographically distributed system. Examining post-war renovation files, particularly from 1953, 1972, and 1998, revealed a pattern of systematic removal. These documents did not merely record repairs, they recorded erasures. The 1953 East Wing Rehabilitation File lists demolition of redundant vaulting beneath subgrade level 2, yet the depot officially has only one subgrade level in that wing. An attached photograph shows workers demolishing a curved stone vault, identical to the sealed doorway beneath track 4. A margin note in engineer Otto Menzel's handwriting reads, "Existing vaulting predates facility. Compromised by wartime damage, must be cleared." The phrase "predates facility" appears nowhere in public renovation summaries. The 1972 modernization describes void stabilization beneath the western concourse. A photograph shows the cavity's edges lined with fused stone. Under material classification, a supervisor noted unknown composition, harder than granite. Chisels produce sparks. Demolition abandoned, filled with concrete instead. The 1998 modernization removed lower corridors entirely. A contractor note states original arch supports removed as unnecessary, not consistent with Victorian-era methods, origin uncertain. The phrasing repeats across 45 years, predates facility, not consistent with documented period, origin unknown. 3 renovation cycles under different political systems treated superior pre-existing structures as disposable obstacles. None of these features appeared in public summaries. Why did 3 programs treat demonstrably superior infrastructure as obstacles, and why were these architecturally significant features never reported in heritage documentation? The depot's lower levels had been steadily erased across the 20th century, as if each generation followed an unspoken protocol: acknowledge privately, dispose of evidence, maintain the official timeline publicly. One document from 1972 stood out. It was a blueprint fragment labeled Hydraulic Inspection Chamber, South Platform Access. The depot records contain no such chamber, yet this was clearly original 19th century drafting with Hartmann's characteristic ink and projection standards. The chamber was drawn as a hollow sphere, 4.2 meters in diameter, connected to 2 conduits, 1.7 meters and 3.4 meters. The same harmonic proportions run throughout the depot's hidden infrastructure. I visited the indicated location beneath the south platform. The floor showed subtle settling. Using ground-penetrating radar, I mapped a spherical void approximately 4 meters in diameter at 6 meters depth, exactly where the blueprint predicted. A hydraulic sphere of this size would require capabilities beyond documented 1890s German engineering. An 1896 Waterworks report describes a similar discovery near the Elbe. It notes a spherical cavity approximately 4 meters in diameter, interior lined with fused stone, no connection to the municipal water system, sealed and backfilled. A colleague studying Central Asian hydraulic architecture noted immediate similarities to pressure regulators in Kokand and Khiva, cities within historical Tartaria boundaries. Those chambers share identical proportions, spherical pressure nodes with proportionally scaled conduits. The depot administration's response was dismissive. They said the void likely represented an undocumented coal storage chamber. Coal chambers are not spherical, do not require pressure-resistant construction, and are not lined with materials harder than granite. Why would an industrial-era station require a pressure-regulating sphere constructed from materials its builders could not produce, using geometric principles their manuals did not describe? Whatever lay beneath Dresden's platforms was not only older than the depot, it was technically superior to it. By this stage, I had enough measurements to identify a clear pattern. 1.7 meters seen in arches, doorways, and conduit diameters. 3.4 meters found in major vault radii and chamber spans. From 9.8 to 10 meters appearing in circular cavities and pressure dome footprints, 10 to 12 degrees, a rotational offset from construction grids. These ratios recurred across every documented anomaly with statistical consistency. I consulted a structural engineer, presenting measurements without context. After calculations, she observed that these proportions are harmonic doublings with a 1 to 2 to 6 ratio. They are efficient for load distribution and pressure equalization. She paused and said, "They are too mathematically precise to be incidental." Her analysis mirrored claims by researchers studying Tartarian infrastructural geometry, systems of harmonics and mirrored proportions in star forts, domes, and subsurface chambers across regions labeled Tartaria on 16th to 18th century European maps. The ratios appeared everywhere in Dresden's records once I knew what to look for. In foundation calculations, excavation sketches, the erased semicircle, and the sealed doorway. An 1896 Hartmann memo states that existing formations display geometric regularity inconsistent with expected soil conditions, not inconsistent with masonry, but inconsistent with soil conditions, as if the geometry predated any construction entirely. The repeating ratios were not style or aesthetic. They were a system older than the depot, older than the 19th century, embedded beneath multiple rail hubs across continents. And that system aligned precisely with what Tartarian researchers describe as remnants of a unified infrastructural network whose geometry survived after its origins were forgotten or erased. If these harmonic ratios were not Victorian, whose system were 19th century builders inheriting? The investigation's final phase required synthesis. I compiled railway stations built from 1850 to 1900 across former Tartarian territories using maps from the 1780s as reference, searching archives for subsurface anomalies. 23 major stations across 11 nations showed evidence of pre-existing infrastructure, identical geometric ratios in excavation reports, similar material compositions, comparable rotational offsets, and consistent documentation, then erasure patterns. Kazan Station in Moscow from 1913 to 1926 recorded circular chambers that were not Tsarist construction, measuring 9.6 meters in diameter with an 11-degree rotation. Warszawa Glona in Poland from 1972 to 1975 records refer to removal of archaic hydraulic systems, 80-centimeter conduits, and pre-industrial composite stone. Almaty 1 station in Kazakhstan has construction journals that reference inherited foundation irregularities measuring 1.7 meters. The geographic distribution precisely overlaps territories labeled Great Tartary, Independent Tartary, or Chinese Tartary on pre-1800 European maps. After 1800, as these regions were absorbed into empires, Tartaria disappeared from cartography, but physical infrastructure remained, buried beneath modernizing cities. What emerged was not conspiracy, but an archaeological pattern. 19th century railway construction systematically built over and erased evidence of an earlier, geometrically sophisticated infrastructure network whose extent matched historical Tartarian territories. I found no coordinated suppression, no secret directives. Instead, there was systematic indifference. Each generation encountered anomalies, documented them internally, and then proceeded as if discoveries held no significance. The pattern suggests not intentional erasure, but a cultural inability to recognize infrastructure so unlike their engineering education that it was easier to classify as irregular or unknown and continue. Yet there was consistent awareness that something older lay beneath. That awareness never translated into preservation or investigation. The question is not whether sophisticated infrastructure once existed across Tartarian territories. Geometric consistency across thousands of kilometers, material properties exceeding period capabilities, and mathematical harmonics make that existence difficult to deny. The question is why that network's existence has been excluded from architectural history despite repeated encounters by multiple generations of engineers. Geometric. The final document I examined was a Prussian Ministry of Public Works memorandum dated 1889, 3 years before Dresden's construction. Declassified in 2003, it addressed railway construction standardization. Section 7, Foundation Assessment Procedures, contained a directive that instructed that where excavation reveals pre-existing stone formations of uncertain origin, assessment should prioritize structural stability. Historical investigation is not required and may delay completion. Standard protocol was to document geometry in internal reports, adapt foundation design, and proceed with construction. Efficiency. This bureaucratic directive established an official policy of documented indifference. Encounter anomalies, note them privately, build over them, never investigate origin. It explains Hartmann's erased semicircle, the sealed doorway's routine treatment, and why renovations in 1953, 1972, and 1998 removed pre-existing infrastructure without archaeological consultation. The policy did not mandate erasure, it mandated efficiency over inquiry. The result was systematic exclusion from the historical record. Indifference. Academic historians I consulted ranged from dismissive, calling it standard construction pragmatism, to cautiously troubled, but none explained why foundations exhibiting mathematical sophistication beyond Victorian capabilities would not warrant investigation before disposal. Historians. One historian suggested that European engineers operated within frameworks that assumed linear technological progress. Encountering infrastructure superior to their capabilities did not fit that framework. Rather than revise assumptions about history, they revised documentation. They classified discoveries as anomalous, emphasized uncertainty, and moved forward. This was not necessarily organized suppression, it was cognitive filtering. But evidence remained. The sealed doorway exists beneath track 4. The ferro-silicate conduit sits in storage. The circular void lies beneath the western concourse. Photographs, blueprints, and records persist in archives across Germany, Russia, Hungary, and Central Asia. Evidence. We have not lost evidence of what researchers call Tartarian infrastructure. We have lost institutional willingness to recognize what that evidence means. Geometric signatures remain. Harmonic ratios persist. Material properties are measurable. Acknowledging their collective significance would require revising assumptions about technological progression and historical timelines. Revisions institutions have shown little appetite for across a century of discoveries. Signatures. I returned to the Dresden depot one final time. Standing near track 4, where the sealed doorway lies 7 meters below, unchanged since 1901, the depot had become something different in my perception. What once appeared as straightforward Victorian construction now felt like a palimpsest, newer text written over older inscriptions that remain visible if one knows where to look. Palimpsest. The 1894 photograph that began this investigation showed workers standing before architecture they did not create, could not explain, and would ultimately bury. They stared into the camera with confidence, unaware they were standing in remnants of something that already was. Photograph. How many cities stand atop similar inheritances? How many construction crews have encountered, documented, and buried evidence that contradicts our timelines? The question had evolved. It was no longer whether sophisticated infrastructure existed across regions labeled Tartaria. Geometric evidence, material analysis, and statistical patterns make that difficult to deny. The real question is why acknowledging that existence remains institutionally unacceptable despite over a century of documented encounters. Alternative researchers studying Tartarian architecture are dismissed as conspiracy theorists, yet they ask questions the evidence demands. What explains identical subsurface geometries across thousands of kilometers that predate engineering standardization? What technology produced materials exceeding Victorian capabilities? Why do official histories remain silent about discoveries their own archives confirm? As I prepared to leave, a depot worker approached, curious about my visits. I showed him the 1894 photograph and explained the arch was somewhere below us. He asked, "So there is old stuff under here nobody talks about?" I answered, old stuff that should not exist according to official history. He nodded. Then he said, "Guess it is easier to pour concrete than rewrite textbooks." His observation captured the investigation's core finding. Physical infrastructure has not disappeared, it has been entombed. Documentary evidence has not vanished, it is archived but unexamined. Knowledge has not been destroyed, it has been classified as irrelevant and then excluded from mainstream discourse. The story does not end because investigation concludes. It ends when someone with institutional authority decides these questions matter enough to investigate properly, with archaeological rigor and intellectual honesty about what the evidence suggests, even if it is uncomfortable. The sealed doorway remains beneath track 4. The photograph never explained what was removed. Across continents, identical signatures persist in structures built decades apart, when such coordination should have been impossible.